Wow, salutations to you out there. Yeah, welcome back. We have another question to solve today. And the question we are solving today is on cyclic quadrilateral. It's on circle geometry. And cyclic quadrilateral happens to be a subtopic under circle geometry. So we are given a diagram like this, and the question is determine the value of m. That means we are looking for this m here. And for us to solve question on circle geometry, we have to put into consideration theorems that are associated to the problem that you are going to solve. Like looking at this particular question now, I cannot find the value of this m directly like this. I have to make some manipulations with this drawing here. So the first thing I will do is to divide this into 2. If I divide it into 2, then I am going to consider, let's clean this side first. So I've divided it into 2. I can label this side A and label this side B. But there is a theorem that is associated with an isosceles triangle. Looking at this now, you will observe that we have 2 isosceles triangles. This is the first part of the isosceles triangle, and we have the second part of the isosceles triangle here. And the theorem associated with isosceles triangle is that the base angles of any isosceles triangle are always the same. That is the first theorem. So if this is the first isosceles triangle, you can see these sides are equal, so the base angle will be equal. If this is A, definitely here too will be A. And if here is B, then here too will be B. So we have this. Then there is another thing that we have to consider from this drawing too. If this side is 80 degrees, then definitely this side too must also be labeled. So here too I can name this side N, because there is also a theorem that is associated with the opposite sides of a cyclic quadrilateral, and the sum of the opposite side of a cyclic quadrilateral are always equal to 180 degrees. So we have n plus 80 will be equal to 180 degrees. That is, the sum of the opposite side of a cyclic quadrilateral is equal to 180 degrees. So my n now will now be 180 minus 80. So my n now will be 100 degrees. I have this one here to be 100 degrees. But of course, we already know that the sum of angle in a triangle is always 180 degrees. That means my n, A, and this A, when you add them together, I am going to have 180 degrees. That means I'm going to have n plus A is equal to 180 degrees. I have gotten the value of n to be 100, so I have 100. Then A plus A will give us 2A. So here I will have 2A is now equal to 180 degrees. So let's make A. My 2A now will now be 180 minus 100. So I have 2A is equal to 80 divided by 2 divided by 2. So 2 will cancel. A now will be equal to 40 degrees. That means A here and here will be equal to 40 degrees. Then we are also going to do the same thing, apply the same thing to this side too. That means I'm going to have 80, as in this 80, plus B, the upper B, and the B here, to be equal to 180 degrees. So I have 2B is equal to 180 minus 80, as in this 80. So my 2B now will now be 100. I divide this by 2, divide this by 2. So my B now will now be equal to 50 degrees. Note that this is where our M is. Looking at this now, you will observe that M now will be equal to the sum of A and B. So M will be equal to the sum of A and B. So automatically, I am going to have my M to be equal to 40 plus 50. So my M now will now be equal to, I have my A to be 40 and my B to be 50. So my M now will now be equal to 90 degrees. As you can see, we apply like 3 laws to solve this particular problem. The first one, we consider the opposite side of a cyclic quadrilateral, whereby we said it's when you add this side and this side together, you must have 180 degrees. Then we also consider the base of an isosceles triangle, and we also consider the last one, which is the sum of angle in a triangle. So we are going to stop here for now, and we take it up from here next time. Thank you for watching. God bless you.